So rational functions, the word rational is just another way of saying fractions. As we see with our parent function here, 1 over x, our x is on the denominator. And there's some important aspects with an x being on the denominator. With fractions, we know that you can't have a 0 in the denominator. We'll see what happens when we have a 0 here in a minute. Now with rational functions, we have what's called asymptotes. As you see here in the picture, notice how my graph is going towards the asymptote, but it's kind of turning away. In my high school class, I call it the cootie line. It's trying to stay away from this line. Now, the standard definition of an asymptote is a line that continually approaches a given curve but does not meet it at any given distance. So you see here, rational functions have both a horizontal and vertical asymptote, and in both directions, horizontally and vertically, my line is curving towards each of these lines, but it's never going to touch or cross. Now, let's go back to what we know about fractions. We cannot have a 0 in the denominator. That's a big no-no. Now remember our parent function, x is in the denominator. If that x happens to be a 0, we can't have that. That's where we get our asymptotes. So as you look here in this example, that's where we get vertical asymptotes if our denominator is 0. I have vertical asymptotes at -2 and -3. Well, why do I have vertical asymptotes at those values? Well, if I plug in -2 for the first set of parentheses in the denominator, -2 plus 2 is 0. Any number times 0 is 0. I can't have a 0 in the denominator. And if I plug in a 3, 3 minus 3 is 0. Can't have a 0 in the denominator either. So those become my vertical asymptotes. Now sometimes it's hidden in there. You may have to factor first. Now part of this class prerequisite is knowing how to factor. So you may have to go see some tutorials, videos online or whatnot on how to factor to remind yourself if you don't know how to do that. But x squared minus 9 is a perfect square, and that factors into x plus 3 times x minus 3. And I need to find out which values for x will make my denominator here 0. Well, that is, of course, -3 and 3. And if I were to graph this, I can see my vertical asymptotes at those values. Now, how to find horizontal asymptotes is completely different. So what we need to do is find my highest power in the numerator and my highest power in the denominator. In the numerator, let me call that highest power n, and the denominator, let me call that highest power d. Now, if my highest power in my numerator is greater than the highest power in the denominator, as you see here in this chart, I will not have a horizontal asymptote. If my highest power in the denominator is greater than the numerator, my horizontal asymptote will be at y equals 0. And if these two happen to be equal, then my horizontal asymptote, I need to look at the coefficients in front of those values. My horizontal asymptote will be a divided by b. Now, what in the world am I talking about? Let's look at a couple examples. So here, notice my highest power in the numerator is a 3, and the denominator is a 2. 3 is greater than 2, which means my numerator is greater than my denominator, so I do not have any horizontal asymptotes. As you see here in the graph, there aren't any. Now the next example, notice how the denominator is greater than the numerator, which means my horizontal asymptote will be at y equals 0. So when your denominator is greater, y equals 0 will become your asymptote. And here we see that both highest powers in the numerator and denominator are equal. They're both 3. So let me look at the coefficients, the number in front, 3 over 2. Therefore, my horizontal asymptote will be 3 over 2. Well, in this case, y equals 3 over 2. So a vertical asymptote is an x equals, a horizontal is a y equals. And that's all you need to know about rational functions, is how to find the asymptotes.